So, hello guys, my name is Izhaan. Currently, I'm pursuing my bachelor's degree in civil and environmental engineering from IIT Patna. So, in the previous session, we were solving the questions on semiconductor devices, and now we just continue from where we left off in the last session. So, so we had question number 25 in our last session, right? And so today we'll be starting from question number 26. So, question number 26 says that two car garages have a common gate which needs to open automatically when a car enters either of the garage or cars enter both. Draw a circuit that resembles this situation using the diodes for this situation. Okay, so this is a very good, nice question. Okay, so I'll show you. Wait a minute. See, I'll consider that what is happening is Y is the gate and A and B are the two cars. Okay. Now, what do they say? There are two car garages have a common gate, okay, which needs to open automatically when a car enters either of the garages or car enters both. Okay. So when car enters neither A nor B, then the gate remains closed. When a car enters A and car does not enter A but enters B, the gate opens. When the car enters A but does not enter B, then also the gate will open. And similarly, when the car will enter A as well as B, then the gate will open. Alright. So, what does this resemble? It seems like an AND to me. So, what is Y? Y is equals to A plus B. Okay. It is an AND circuit. Alright. Simple. So, if you want to draw the circuit, you can just, this is an OR gate. Or yes, OR circuit. So since it is an OR circuit, you can draw it like this: A, B, Y. Okay, simple circuit. So next up, the question is, how would you set up a circuit to obtain NOT gate using a transistor? Okay. So first of all, we have to consider a device where there is only one input and there is only one output, and the Boolean expression will be A dash. Okay. See, first of all, you have to see what a NOT gate is. Suppose this is A. This is the NOT gate, and it is reaching what? Y. So Y is equals to A dash, or similarly, we can say A is equals to Y dash also. Okay. So the transistor is a biased collector voltage device. Okay. Now the resistor R and can be chosen in it. So if the input is low, the transistor will be in the cutoff, and when the voltage will be appearing in the output, the voltage will increase in the transistor. So if I want to draw the circuit for this, for the transistor, okay, I'm giving it a source voltage over here, okay, grounding. This is a switch AB, alright. Now, okay, so यहाँ से कंटिन्यू होगा RB एंड यहाँ पे एक ट्रांजिस्टर लगा देंगे. This will go to a C point. This will go to a emitter point E. हम लोग जानते हैं यहाँ पे करंट फ्लो होगा. Emitter will be grounded. Okay. सी पॉइंट से आगे जाएंगे, ठीक है, सी पॉइंट से, ऑलराइट, और ऊपर की तरफ क्या होगा, एक रेजिस्टेंस होगी आर, ठीक है, फिर से एक सोर्स होगा वी वोल्ट का, और ये भी आगे जाके ग्राउंड हो जाएगा, ये जाके मिलेगा वाई से इन ओपन सर्किट, इसको हम लोग क्लोज कर सकते हैं, और यहाँ पे ग्राउंडिंग हो जाएगी। ओके, सो ये होगा सर्किट। तो अगर मैं ए की वैल्यू रखूंगा, तो यहाँ पे वाई देखूंगा, ए की वैल्यू अगर 0 है तो वाई की वैल्यू 1 है, ए की वैल्यू 1 है तो वाई की वैल्यू 0 है, दिस मींस दैट वाई इज इक्वल्स टू ए बार, और ये हो गया उसका करस्पॉन्डिंग सर्किट यूजिंग अ ट्रांजिस्टर। ओके, see, to remind you of the theory behind this, you have to realize it as a NOT gate. Alright, so the transistor is so biased that the collector voltage VCC will correspond to one state. Now the resistor R and RB will be chosen in such manner that if the input is low, such as the input is 0, okay, the transistor will be in the cutoff, and hence the voltage appearing at the output will be the same as applied. See, as applied here, over here will be 5 volt. So in output you will see a 5 volt when the input is 0 volts. So if the input will be high, the transistor current is in the saturation and the net voltage at the output will be 0, because the circuit will act as a broken situation and the net voltage at Y will be max. So that is what we have tried to do over here. Now we have question number 28. Explain why elemental semiconductor cannot be used to make visible light emitting diodes. Okay, elemental semiconductor cannot be used to make visible LEDs. Okay, so what happens is, if you see a PN diode, okay, and it is in the forward bias condition, so the band gap, like this is band 1, this is band 2. So this band gap is there, and when an electron jumps from here to here, there is an energy release or emission. And emission is there. All right. First of all, you have to understand this. So what happens is, when you use those light emitting diodes, they are basically what, they are gas for gap, like gas type of diodes. So what will happen is, when the electrons will jump from band 1 to band 2 in these situations, they emit light energy. All right. But when you use an elemental semiconductor, the band gap is such that the emission will be in the infrared region. It will not be in the visible region. So that is the basic, like I'll show you over here. Lambda is what, at C upon E. C upon E. So I can write 1242 electron volt per nanometer divided by E. And for silicon, if you talk about, band gap Eg is equals to 1.1 electron volt. So it will be 1242 upon 1.1, it's equal to 1129 nanometers. All right. And similarly for germanium, if we talk about energy, Eg is equal to 0.7 electron volt, we already, it will be 12.42 upon 0.7. So it will be what? 1774. 1774 nanometers. So when the elemental semiconductor is used, the band gap is such that the emission will be in the infrared region and not in the visible region. So that is the main reason that it cannot emit light. Okay. So now question number 29. Write the truth table for the circuit shown in the figure 14.11. Name the gate that the circuit resembles. All right. Okay, so we have to, you know, suppose that where is the circuit? A and B is there, na? Plus 5 volt over there, and D1 से पहले है 0 volt. Okay, तो यानी D1 से पहले ग्राउंडिंग हो रखी है. ओके, तो अब एक बात समझेंगे दैट इट कैन बी कंसीडर्ड दैट इट हैज टू इनपुट्स ए एंड बी. ए एंड बी दो इनपुट आ रहे हैं और यहाँ पे कुछ है और यहाँ पे एक आउटपुट जा रहा है वाई. अभी इतना पता है. सो बूलियन एक्सप्रेशन क्या बनेगा वो हम लोग को देखना है. तो व्हेन ए एंड बी बोथ आर जीरो, a is equals to 0 and b is equals to 0, so the voltage supply through R is forward biased diodes D1 and D2. The voltage V would drop across R. So the output voltage at Y will be the voltage across diode, which is 0. So Y will be 0. Moving on. When A will be equal to 0 and B will be equal to 1. So B1 will conduct D1. When B is equals to 1, then what will happen? D1 will conduct, but D2 does not conduct. Wait. So when A is equals to 0 and B is equals to 1, then the D1 will conduct. Okay, but the D2 does not conduct. It will not conduct. Then, okay, similarly for when A is equals to 1 and B is equals to 0, then D1 will not conduct, whereas D2 is going to conduct. All right. And lastly, when A is equals to 1, B is equals to 1, then what will happen? None of the diode will conduct. None will conduct. So this forms my truth table. All right. Now, if I want to draw my truth table, let's write it over here. A, B, and voltage V. So 0, 0 पे what was there? Y was 0. 0, 1 पे what was there? It was a 0. 1, 0 पे it was a 0, and only on 1, 1 I had a voltage of 1. So what does this resemble? This does resemble the truth table for an AND gate. So if I want to write, I can write it as this. A आया, B आया, AND हुआ, and then Y मिल गया. Simple. Alright, so now moving on, we have question number 13. So a zener of power rating 1 watt is to be used as a voltage regulator if zener has a breakdown of 5 volt and it has to regulate voltage which fluctuated between 3 volt and 7 volt. What should be the value of RS for safe operation? Okay, so a zener has a power rating of 1 watt, and it is to be used as a voltage regulator. Breakdown of 5 volt, and it has to regulate voltage which fluctuated between 3 to 7. What should be the value of RS for safe operation? Okay, now we have unregulated voltage on this side. Unregulated voltage over here. Now we have an RS over here coming down a zener diode over here. Moving forward, the regulated voltage over here. Nice. So according to the problem, the power is equals to 1 watt. Zener breakdown voltage VZ is equals to 5 volt. Now minimum V minimum is equals to 3 volt and V max is equals to 7 volt. Alright. Now power is equals to VI, we already know. Yeah? So I in Z max condition will be P upon VZ, which will be 1 upon 5, which will be 0.2 amperes. Alright, for safe operation, RS will be equal to what? RS will be equal to V max minus VZ upon IZ max. So 7 minus 5 divided by 0.2 is 2 upon 0.2. It will be 10 ohms. Alright. So question number 31st. If each diode in figure 14 contains a forward biased resistance of 25 ohms and infinite resistance in reverse bias, what will be the value of the current I1, I2, I3 and I4? If each diode in figure has a forward bias resistance of 25 ohms. Okay. And an infinite resistance, obviously infinite resistance will be there in reverse bias. What will be the values of the current? I1, I2, I3 and I4. Alright, so it is simple question. So only the branch CD is having a reverse bias condition. Alright, so current in that branch will be 0. I3 will be 0. I'll draw it over here and then I'll mark the currents. First I'll draw the circuit, okay? So I have a 5 volt over here. So this is the positive part, this is the negative part. We already know this. This is a 25 ohm over here. Alright, then it will go up. This diode is forward biased. Alright, there is a 125 ohm over here. I'll say that this is the current I4 over here. I4. Now coming from this side, this is the reverse bias condition. Okay, 125 ohm over here. But since the resistance due to this will be infinite, R will be infinite, the value of the current I3 will be equal to 0, right? Now, okay, forward bias condition. There's a 25 ohm resistance due to this diode and 125 ohm over here. And this is the current I2. Finally, we have a current I1 which is leaving this battery. So, the resistance in branch, I'll name them A, B, CD तो ignored, CD इसको तो ignored कर दो. There's nothing over here, and EF. So now, if I want to write, then the resistance in the branch AB will be equal to 25 plus 125, which will be 150 ohm, and I'm going to say that this is my R1. Now, the resistance across the branch EF will be 25 plus 125. I can write it as 150 ohm, which will be nothing but my R2 now. Alright. Now, what is next? Okay. So since these two branches are in parallel, then I can add these resistances R net, and 1 upon R net is equals to 1 upon R1 plus 1 upon R2, which will be 1 upon 150 plus 1 upon 150. This means 2 upon 150. It means 1 upon 75. So R net will be nothing but 75 ohms. Alright. Now I'll draw the new circuit over here. There's a battery. There's some resistance over here. Going onwards, there's a 75 ohm resistance over here. Okay, and the resistance over here is 25 ohms. 5 volt battery. Alright. Now the net resistance across the circuit R dash will be 25 plus 75 as they both are in series. Okay, so it will be 100 ohm. And the current that will be leaving the circuit I is equals to V by R dash, so 5 upon 100, it is equals to 0.05 amperes. So now we have to apply the Kirchhoff's law. So the I which is leaving here, I1, it will be equal to the I which went through each of the branches. So 2, 3 and 4, I1 is equals to I2 plus I3 plus I4. We already know I3 ka current is 0, so I1 will be equal to I2 plus I4. Now, since the resistance in R1 and R2 are same, then I4 is equals to I2 हो जाएगा and I1 is equals to 2 times of I2 हो जाएगा. So I2 is equals to I1 upon 2, which is equals to 0.05 divided by 2, which is equals to 0.025 ampere. And similarly, I4 की भी वैल्यू सेम हो जाएगी 0.025 ampere. And hence हम लोग को सारे करंट्स मिल चुके हैं. I1 निकला हुआ एटलीस्ट 0.05 एम्पेयर, I2 हो गया 0.025 एम्पेयर, I3 हो गया 0 एंड फाइनली I4 हो गया 0.025 एम्पेयर. ऑलराइट. Now, question number 32. In the circuit shown in figure, when the input voltage of the base resistance is 10 volt, VBE is 0. And VCE is also 0. So now find the value of IB, IC and beta. Okay. So first of all, I'll draw the circuit. यहाँ पे 10 वोल्ट है. ओके. RC हमें दिया गया है 3 किलो ओम. यहाँ पे है V input. This resistance RP is over here, which is equals to nothing but 400 kilo ohms. Okay. So according to the problem, we already know V input is equals to 10 volt, resistance RB is equals to 400 kilo ohm, voltage across BE is 0, voltage across CE is 0, and RC is equals to 3 kilo ohm. All correct. So now I'm starting. So V input minus VBE, which is the potential drop, is equals to RB times IB. Okay. And now IB is the V voltage across RB divided by RB. Simple. And now if I want to write it, it will be 10 upon 400 into 10 to the power of 3. So it will be 25 into 10 to the power of minus 6 ampere. It will be 25 microampere. Okay. Now voltage across V across RC, it will be 10 volt. So VCC minus VCE will be ICRC. Okay. So IC will be voltage across RC. By RC. So it will be 10 upon 3 into 10 raised to the power of 3. 3.33 into 10 raised to the power of minus 3 ampere. I can write it as 3.33 milliampere. Alright. Now beta is nothing but IC upon IB. So 3.33 milli divided by 25 micro. So it will be what? Okay. So it will be 33.3 into 4. 4 is 12. 2, 1. 2 is 12. 1, 1, 3, 1, 1, 3. And 133. 133.2. Say. Okay. Now moving forward, we have question number 33. So draw the output signal C1 and C2 in the given combination C1 and C2. Output signal C1 and C2 in the given combination. अच्छा. Input and out दिया हुआ है. Input ग्राफ के साथ दिया हुआ है. At t equal to 0 second पे देखो A is equals to 1 and B is equals to 0. And at t equal to 1, A is equals to 1 and B is also equal to 1. So ऐसे करके चलना है इसमें. Alright. Now if I want to draw and C1 भी है C2 भी है ना. So let's just start over here. And right, देखो पहले यहाँ से ए जाएगा, एंड होगा, ए गया एंड हुआ, सी बना, सी को हम लोग नॉट कर देते हैं, ई बनेगा, ई नीचे आ जाएगा। सिमिलरली यहाँ से बी जाएगा, बी जाएगा, एंड होगा, डी बनेगा, नॉट होगा, एफ बनेगा, आगे जाके एंड होगा, जी बनेगा, नॉट होगा, एच बनेगा, एंड होगा, एल बनेगा, फिर नॉट होगा, फाइनली सी बन जाएगा। तो इसके लिए अगर मैं ट्रुथ टेबल लिखूं तो ए बी सी डी ई एफ जी एच आई C1, A 0 0 0 सॉरी 0 0 1 0, ठीक है, 0 1 एंड 1 1। तो सी यहाँ पे क्या क्या होगा, सी के लिए ए अगर 0 है तो सी विल बी 0 1 0 1, ठीक है, 0। और इसी तरह से डी क्या है, बी के साथ साथ चल रहा है तो डी विल बी 0 0 1 1। ई यहाँ पे क्या होगा, सी का नॉट, तो ई विल बी 1 1 0 1 0 1 0 1 0, and similarly F will be D का not तो 1 1 0 0. Okay, now moving onwards to G. G is the AND of E and F. तो E and F का अगर AND करूंगा तो 1 1 पे तो सही है 1, otherwise इस पे भी 0, इस पे भी 0 and इस पे भी 0. Now G मिल गया, then we have to get to the H. So H is just the not of G. It will be 0 1 1 1. Now I, what is I? I is the end of H. So 0 it will be 0, and rest it will be 1. And finally 0 0. Alright, simple graph. And now moving on, I'll draw the next part, which is the final question. यहाँ से A चलेगा, यहाँ पे और होगा, C मिलेगा, नॉट होगा, E मिलेगा।
हेलो इज़हान,
हेलो, यस सर।
हाँ, मैं ये कह रहा हूँ इस क्वेश्चन को हमें फिर से करना होगा।
ओके सर, ओके, ऑलराइट।
या
Okay, so next question is question number 33. So we have to draw the output signal C1 and C2 in the given combination. Alright, और इसका input waveform it has been given to us in the form of a graph. Like when t equal to 0, A की value है 1, B की value है 0, and so on. You'll understand it. Okay, so moving onwards. So if you just want to draw it, whatever the like circuit has been given to me, I'll just redraw it and then it will be fine. यहाँ पे नॉट है, हम लोग E पे आ गए, ये पॉइंट है C, ठीक है, यहाँ पे फिर हम लोग और पे आ गए, हम लोग G पे आ गए, G के आगे again there's a knot, and then finally I'm having a C2 over here. So I'll just write it down: A B C D E F G C2. So A की वैल्यू 0 1 0 1, B की वैल्यू 0 0 1 1. So then C की वैल्यू is the AND of A, and it will be 0 1 0 1, same as A. Similarly, D will be the same as B, and E will be what? E will be C का उल्टा, 1 0 1 0. F will be what? D का उल्टा, it will be 1 1 0 0. G will be the AND of previous both, so it will be 1 1 1 0, and C2 will be just ulta of this, so 0 0 0 1. Now if I want to write it, I can write it as what? C1 is equals to A dash dot B dash the whole dash. Now this can be seen as equal double dash, double dash, yeah. So it can be seen as A double dash plus B double dash Q per A dash. So it can be seen as A plus B whole Q per A dash. So this will be the value for C that. Alright, moving onwards, I have question number 34. So consider the circuit arrangement shown in favor for studying input and output characteristics of an NPN transistor. So in C configuration, select the value of RB and RC for a transistor whose VPE is 0.7 volt so that the transistor is operating at point Q as shown in the characteristics. So now I'm just doing the solution. You can already see the circuit over here and the characteristic graph over here. So what is happening? I'm just writing it down. VBE is equals to 0.7 volts. VC is equals to VBB, which is equals to 16 volts. And VCE is equals to 8 volt. Now IC is equals to 4 milliampere. 4 into 10 is to the power of minus 3 amperes. IB is equals to 30 microampere. It will be 30 into 10 is to the power of minus 6 amperes. Okay. So now VCC is equals to ICRC plus VE. The way as RC is equals to VCC minus VCE upon IC. It will be 16 minus 8 upon 4 into 10 is to the power of minus 3. This will be 8 into 10 is to the power of 3 divided by 4. So it will be nothing but 2 kilo ohms over here. Now for VBB, so if I move on for VBB, it is equals to IB RB plus VBE. So as you know, we were calculating for VBB right now. Okay, VCC we already did, and now for VBB, IB RB plus VBE will be the equation. So now I'm writing for RB. So RB will be what? VBB minus VBE divided by IB. And we already know the values for them 16 minus 0.7 and it IB was 30 micro. So it will be 10 to the power minus 6. So यहाँ पे हम लोग लिखेंगे 16 minus 0.7 divided by 30. 510 kilo ohm, correct. So it will be 510 kilo ohms. Alright. Now again, beta is nothing but IC upon IB, and we already know the value for both of them. So just put the values over here, and you'll get it 4 divided by 30. So voltage gain, V gain beta C by RB. So it is 133 into 2 into 10 is to the power of 3 divided by 510 into 10 is to the power of 3. Okay. 133 266 divided by 510. So voltage gain आ जाएगा voltage gain beta RC by RB 0.52 and now power gain beta times voltage gain. It will be 133 into 0.52. It is nothing but what? 16. Alright. So you question over here. Now next up, I have question number 35. So assuming the earlier level, draw the output waveform for the circuit given the figure explain the waveform. तो ये तो मतलब काफी सिंपल क्वेश्चन है. हम लोग को बस ऊपर का कट ऑफ 5 वोल्ट कितना है बस प्लस 5 वोल्ट के ऊपर हम लोग को नहीं जाना है ड्यू टू दिस डायोड. लेट्स सी दिस. तुम पूरा उसका जितना भी है देखो, ये होता अगर डायोड ना लगा होता. ठीक है, अब यहाँ तुम कैप लगा दो प्लस 5 वोल्ट पे. ठीक है, ये फॉरवर्ड बायस में केवल ऐसा होगा. ये कैप तुमने लगा दिया. नाउ ड्रॉ स्ट्रेट लाइन ओवर हियर. इतना पार्ट उड़ा दो. तो the final graph which will be drawn will be यहाँ से यहाँ तक फिर सीधा फिर नीचे, फिर यहाँ से यहाँ तक सीधा फिर नीचे, फिर सीधा फिर नीचे, like this. Understood ना? And this straight line will be plus 5 volt time. Okay. So now moving on, I have a question number 36. Suppose N wafer is created by opening silicon crystal having 5 into 10 raised to power 28 atoms with 1 ppm concentration of arsenic on the surface of 200 ppm boron is added to a p region in the wafer. Considering this, calculate the densities of the charge carriers in the N and P regions. Okay, so it is basically a formula based question. Okay, nothing special is there. So what is happening? N electron equal to N d, and let it as 10 is power minus 6 into 5 into 10 is to 28 atoms per meter cube. So it will be 5 into 10 is to power of 22 atoms per meter cube. Alright. The number of minority carriers in N type are like Ni square upon Ne, it will be 1.5 into 10 is to power of 16 the whole square and divided by the N electron. N electron will be 5 into 10 is to power 22. यहाँ पे निकाला हम लोग ने. So इसको हम लोग अगर कैलकुलेट करें 0.45 into 10 raised to power of 0.45 into 10 raised to power of 10 per meter cube डेंसिटी है होल्स की. ऑलराइट. नाउ पी टाइप वेफर अगर हम लोग को बनाना है तो उसमें नंबर ऑफ होल ज्यादा रहेंगे. सो व्हेन बोरॉन इज इम्प्लांटेड ऑन सिलिकॉन क्रिस्टल देन Na will be 200 into 10 raised to power of minus 6 into 5 into 10 raised to power of 28, 5, 200, 1000, 20 minus 22, 1000, 1 into 10 raised to power of 25. 1 into 10 raised to power of 25 atoms per meter cube is the density of Na. And now in the p-type minority carriers will be what? Electrons. So number of electrons n square upon n holes. So it is 1.5 into 10 raised to the power of 16 the whole square divided by what? 1 into 10 raised to the power of 25. So I'll just write it down. So 15 to 25. Okay, so 25 to 32. 32 7. So 2.25 into 10 raised to the power of 7 per meter cube. And the explanation will be the minority carrier holes of N region wafer. Okay, minority carrier in N region, the minority carriers will be what? Holes, the NH is equals to 0.45 into 10 raised to the power of 10 per meter cube. It would contribute more to the reverse saturation current than minority carriers, which will be the electron of P region. Okay, it was simply a formula based question over here. An XOR gate has been made for us, and the values have been given. So the value for will be A, B, and Y. It is represented by the following. Build this gate using AND or and NOT gates. Alright. We will listen. Okay. ये गेट बनाना है तो if I want to write the equation for this, what will it be? The equation for y. Y will be what? Y could done 0 or and if I do and it will be 0. Not gate use करना है and और gate use करना है, right? एक अगर मैं नॉट करूंगा तो आ जाएगा 1. 1 का b के साथ एंड कर दूंगा 0 हो जाएगा और 0 का एंड करना पड़ेगा दूसरे 0 से. ठीक है, सिंपल है. तो y कैन बी रिटन एज a डैश b, ये एंड है और a. बिल्कुल परफेक्ट, सारी वैल्यूज इसमें सेटिस्फाई हो जाएंगी. ये तो बनाना सिंपल ही है हम लोग के लिए. यहाँ से मैं a को निकालूंगा, इसको नॉट कर दूंगा, ठीक है, और एक एंड में डाल दूंगा. ये आगे जाएगा y1 बना के देगा. ये पार्ट जैसे y1 है, मैं ये मान रहा हूँ, भी assume कर रहा हूँ ये पार्ट है y1 और माय दिस पार्ट इज y2. ऑलराइट, ये a यहाँ से गया था. नाउ मैं एक b निकाल दूंगा यहीं से और b को अभी नॉट नहीं करूंगा, अभी डायरेक्ट जोड़ दूंगा. a की एक पोर्शन लेके जाऊंगा बिना नॉट करे, इसको जाके इधर जोड़ दूंगा दूसरे में. b का एक पोर्शन लेके जाऊंगा, उसको नॉट कर दूंगा. ठीक है, तो ये मेरा परफेक्ट y1 और y2 तो बन गया. ठीक है ना. a डैश बी प्लस ए डैश बी भी बन गया, ए बी डैश भी बन गया. अब बस इन दोनों का और करना है, तो यहाँ पे और लगा दूंगा. देन फाइनली मेरा y मुझे मिल जाएगा. सिंपल. Now question number 38. Consider a box with 3 terminals on top of it as shown, A, B and C. Three components, namely two germanium diodes and one resistor, are connected across the three terminals in some arrangement. A student performs an experiment in which any two of these three terminals are connected in the circuit as shown in the figure. The student obtains a graph of current voltage characteristics for unknown combination of components between two terminals. The graph where A is positive and B is negative, when A is negative and B is positive, when B is negative, C is positive. Okay. अरे तो ये सिंपली डायोड्स और उनके ग्राफ है. फ्रॉम दीज ग्राफ्स ऑफ करंट वोल्टेज कैरेक्टरिस्टिक डिटरमाइन द अरेंजमेंट ऑफ कंपोनेंट्स बिटवीन ए बी एंड सी. ठीक है. वी आई कैरेक्टरिस्टिक दी हुई है. इन वी आई कंडीशन 1 देखो, वी आई कंडीशन 1 देखो पहले दिस. ठीक है. A reverse characteristic is shown. Here A is connected to N side of PN junction diode and B is connected to top side of PN junction diode and resistance series. ठीक है. अब वी आई कंडीशन 2 देखो. A forward characteristic is shown. यहाँ पे 0.7 वोल्ट जो है वो नी वोल्टेज है पीएन जंक्शन का और स्लोप हो गई 1/1000. So it means A is connected to N side of PN junction and B is connected to P side of PN junction and resistance R is in the series of PN junction between A and B. Now third part देखो. ठीक है. ये तो बहुत बेसिक ग्राफ है. सो इट इज अ फॉरवर्ड कैरेक्टरिस्टिक ग्राफ और यहाँ पे जो 0.7 वोल्ट है it is also the knee voltage and in this case the P side of PN junction is connected to C. Now जो बाकी भी तीन ग्राफ हैं वो कंक्लूड यही करेंगे कि हमारा PN जंक्शन जो है अलॉन्ग विद द रेजिस्टेंस उसका अरेंजमेंट वैसा ही है. B से डायरेक्ट देखो मैं पहले बनाता हूँ B C एंड फाइनली A. अभी तक हम लोगों ने क्या कंक्लूड किया? B जुड़ा है P टाइप से और C जुड़ा है N टाइप से. ठीक है. और यहाँ पे अगेन P एंड रेजिस्टेंस R वो जाके मिल रहा है A में. सिंपल ग्राफ. मूविंग फॉरवर्ड आई हैव क्वेश्चन नंबर 39. So for the transistor circuit shown in the figure, okay, this is the transistor circuit. Calculate VE, RE given IC is equals to 1 milliampere, VCE is 3 volt, VBE is 0.5 volt and VCC is 12 volt. Okay, और बीटा दिया हुआ है, गेन दिया हुआ है हम लोग को. All right. Okay, so इसके लिए हम लोग को ग्राफ बनाना पड़ेगा. This is my VCC which is nothing but 12 volts. I have an RB over here. Okay, यहाँ पे आएंगे तो 20 किलो ओम दिया हुआ है. यहाँ पे ग्राउंडिंग हो रखी है. ठीक है. यहाँ पे RC is equals to 7.8 किलो दिया रखा है. इसको मैं एक ट्रांजिस्टर से जोड़ दूंगा. RE दिया हुआ है और ये जाके जुड़ रहा है अर्थिंग में. सामने से ये आ रहा है. राइट. तो यहाँ पे मैं मानूंगा मेरा IC करंट जा रहा है. यहाँ पे मैं मानूंगा मेरा IB प्लस I करंट जा रहा है. इसकी वैल्यू पता मुझे 100 किलो. ठीक है. यहाँ पे मानूंगा IB करंट जा रहा है. ये जो ड्रॉप है यहाँ पे उसको मैं कहूंगा VBE जो कि दिया हुआ है 0.5 वोल्ट. रेजिस्टेंस दिया हुआ है 20 किलो. यहाँ की रेजिस्टेंस दी हुई है. यहाँ पे VC और IC इन दोनों के बीच का जो पोटेंशियल डिफरेंस VCE है वो है 3 वोल्ट. तो सारी चीजें हो गई. नाउ IC will be approximately equal to IE and where RC is equal to 7.8 kilo ohms. So from the figure you already know IC is equal to RC plus RE plus voltage across CE which is equal to 12. And now I can write it as RE plus RC into 10 to the power of minus 3 plus 3 will be equal to 12. RE plus RC कितना है? 9 किलो. Okay. So I can write it as simply RE is equal to minus 7.8. RE होगा 1.2 किलो ohms. ठीक है. VE मैं कहता हूँ IE into RE है. So I can write it as 1 into 10 to the power of minus 3 into 1.2 into 10 to the power of 3. तो ये हो जाएगी 1.2 volt. Now I'll write VB is equals to VE plus VBE which will be 1.2 plus 0.5 which will be equal to 1.7 volts. Alright. Now current I in the circuit में कहता हूँ VB upon 20 into 10 to the power of 3 which will be 1.7 upon 20 into 10 to the power of 3. It will be 0.085 milliampere. ठीक है. Resistance RB will be equal to 12 minus 1.7 upon IC by beta plus 0.085 into 10 to the power of 3. So it will be 10.3 upon 0.01 plus 0.085. तो इसको मैं फाइनली लिख सकता हूँ 108 किलो ओम. आरबी की वैल्यू हो गई 108 किलो ओम. डन. नाउ लास्ट क्वेश्चन इन द सर्किट शोन इन द फिगर फाइंड द वैल्यू ऑफ आरसी. ये भी सिमिलर टाइप का क्वेश्चन है जैसा भी हम लोग ने सॉल्व किया है. अगेन वही चीज है, आई ई इज इक्वल टू आई सी प्लस आई बी, और आई सी की वैल्यू दूसरी तरह से लिखने का मतलब है बीटा आई बी. ठीक है. नाउ आई सी आर सी प्लस बी सी ई प्लस आई ई आर ई इक्वल टू बी सी सी. ठीक है. आर आई बी प्लस बी बी ई प्लस आई ई आर ई इक्वल टू बी सी सी. Since this is true, it will be equal to beta IB. So R plus beta RE will be equal to VCC minus VBE, and therefore I can write my IB as VCC minus VBE R plus beta RE. It will be 11.5 on 200 milliampere. So RC plus RE equal to VCC minus VCE on IC. तो यहाँ पे आ जाएगा VCC minus VCE upon R plus beta RE. It will be 11.5 divided by 200 milliampere. So from 2 we have RC plus RE equal to VCC minus VCE upon IC. ठीक है. IC को मैं क्या लिख सकता हूँ, बीटा टाइम्स आई बी है ना. So it will be 2 upon 11.5, 12 minus 3 kilo ohm, and it will be nothing but 1299 and 18 divided by 11.5. 51.56 kilo ohm. So it will be 1.56 kilo ohm. Now finally, I write now RC is equal to 1.56 minus 1, which will be nothing but 0.56 kilo ohm. And hence we conclude our topic on semiconductor devices. I'll see you in the next session. Thank you and all the best.